In this video, you will understand the basic properties of electric charge. In the previous lecture, I have discussed about electric charge and the difference between electric charge and mass. In this lecture, I will be going to explain about the basic or the fundamental properties of electric charge. Number one property is additive nature of electric charge. So what exactly is the additive nature of electric charge? If I would consider a body or a system, then the total electric charge present on the body or the system is equal to algebraic sum of all the individual electric charges located at different points of the body. Let us consider I have a body or a system. Let us consider this as a body. Okay. So if I would consider the several charges are present. For example, Q1 charge is present here, Q2 charge is present here, Q3 charge is present here, Q4 charge is present here. And let us consider the n number of charges are present. N number of charges are present on this particular body. So if I would say what is the total electric charge on this body or the system? So total electric charge on a body or a system for this case would be represented as the algebraic sum of all the individual electric charges. So it can be considered as Q1 plus Q2 plus Q3 plus Q4, and if I have n number of charges present on the body, so I would consider this to be Qn. So this is the total electric charge present on the body, and it is denoted by just Q. It is denoted by Q. So this shows the algebraic expression or the algebraic addition of the charges. This is referred to as additive nature of electric charge. Let us consider a case if a body contains 4 charges. If a body contains 4 charges, the charges are plus 2 microcoulomb, minus 3 microcoulomb, plus 4 microcoulomb, and minus 5 microcoulomb. This is the symbol for the microcoulomb. Microcoulomb, which means 1 microcoulomb is equal to 10 to the power minus 6 coulomb. Okay. So if I would consider a body containing 4 charges present, let us consider this as a body in which it has plus 2 microcoulomb, minus 3 microcoulomb, plus 4 microcoulomb, minus 5 microcoulomb. So what is the total charge Q on the body? So total charge Q on the body or system, I would say, what exactly it is. So according to the previous one, it is the sum of the algebraic values of the individual charges. So we need to add all these charges: plus 2 microcoulomb, plus minus 3 microcoulomb, plus 4 microcoulomb, plus minus 5 microcoulomb. So on solving this particular, we get minus 2 microcoulomb. So this is the total charge Q on the body. Okay. Next property of the electric charge is that it is quantized. It follows the principle of quantization of electric charge. So what exactly is the meaning of quantization? This is a very interesting concept. Quantization का मतलब है पैकेट्स फिक्स्ड अमाउंट. यानी कि अगर हम एक स्मॉल चार्ज को समझते हैं तो स्मॉल चार्ज विच एग्जिस्ट इंडिपेंडेंटली इज द चार्ज ऑन इलेक्ट्रॉन. और प्रीवियस लेक्चर में हमने बताया है द चार्ज ऑन 1 इलेक्ट्रॉन इज 1.6 इंटू 10 रेज टू द पावर माइनस 19 कूलम, एंड दिस वैल्यू इज द फंडामेंटल चार्ज. दिस कैन बी कंसिडर्ड एज द फंडामेंटल. इससे बेसिक चार्ज की जो इलेक्ट्रॉन है उसमें कितना अमाउंट ऑफ जो चार्ज प्रेजेंट है इससे कम तो नहीं हो सकता. दिस इज द फंडामेंटल चार्ज और द बेसिक चार्ज. सो चार्ज ऑलवेज प्रेजेंट इन इंटीग्रल मल्टीपल ऑफ दिस फंडामेंटल चार्ज. दिस इज द क्वांटाइजेशन ऑफ इलेक्ट्रिक चार्ज. मतलब किसी भी बॉडी में कोई भी चार्ज प्रेजेंट होगा, इट विल ऑलवेज एग्जिस्ट इन द इंटीग्रल मल्टीपल ऑफ दिस पर्टिकुलर वैल्यू, 1.6 into 10 to the power minus 19 coulomb. Let us consider a case. For example, I would consider 1 electron, 2 electron charge, 3 electron, 4 electron charge, and I would consider n electron charge. So this is shows the integral multiple. Here you can clearly see 1, 2, 3, 4 and n. These are the integers. So integral multiple of the charge on one electron. If I would say the negative values, minus 1 electron, minus 2 electron, minus 3 electron, minus 4 electron, and somewhat like that, minus n electron. So this also follows the integral multiple of the fundamental charge, because 1 and minus 1 integers, 2 and minus 2 integers, 3 and minus 3 integers, 4 and minus 4 integers, n and minus n also an integer. But what if I say 2.5 electron? So it is very clear that 2.5 is not an integer. It is not an integer. Okay, it's a decimal value. It's a decimal value. Hence, it violates the quantization rule. Quantization rule में क्या बोला गया है? Exist in the integral multiple of the fundamental charge. That is why 2.5 electron cannot exist. Cannot exist. For example, if I would consider as a fractional value, like suppose 7 upon 3 electron, I would consider two possible values, plus value and minus value. More specifically, plus 7 upon 3 electron and minus 7 upon 3 electron. So these two represents the fractional value. Fractional value. These are again not integer. Not integer. Okay. So on dividing these fractions, we will get something like decimal values. That is why this cannot also exist, because it violates the quantization of charge. Because according to the quantization principle of charge, charge always exists in integral multiple of the fundamental charge. So we can write it as follows: Q is equal to positive, negative n and charge on one electron. This shows what? Here Q represents charge on body or the system. Here n represents, it should be an integer. It should be an integer. And E, electron, shows the charge on electron or the fundamental charge, that is 1.6 into 10 to the power minus 19 coulomb. So this is the particular mathematical expression showing the quantization of electric charge. Let us consider a very basic question. For example, can a charge of 8 into 10 to the power minus 19 coulomb be given to a body? किसी बॉडी को हम इतना चार्ज प्रोवाइड कर सकते हैं क्या? किसी बॉडी में इतना चार्ज प्रेजेंट हो सकता है, एग्जिस्ट हो सकता है? सो हाउ विल यू अप्रोच दिस टाइप ऑफ बेसिक क्वेश्चन? सो वी नो दैट the expression for the quantization rule shows Q is equal to positive, negative and E. So Q is equal to positive, negative n charge on an electron. Okay. So the charge which we have given is Q, 8 into 10 to the power minus 19 coulomb. We know the charge on one electron is 1.6 into 10 to the power minus 19 coulomb. So on putting the values in this particular expression, 8 into 10 to the power minus 19 coulomb, positive, negative n into 1.6 into 10 to the power minus 19 coulomb. On solving, the value of n will become 8 into 10 to the power minus 19 coulomb, 1.6 into 10 to the power minus 19 coulomb. On dividing, I would cancel out these values, 10 to the power minus 19 coulomb and 10 to the power minus 19 coulomb. I get the value 8 upon 1.6, or more specifically, this get reduced to something like that, 80 upon 16. We should not ignore the sign as well, because here there is positive negative any, so we must approach here positive negative. This comes out the value 5, because 16 times 5 is 80. So here we got the values of n is positive negative 5, so it is an integer, and according to the quantization rule it should be an integer. So if the n means the number of electrons is an integer, so I would consider that yes, a charge, given charge of 8 into 10 to the power minus 19 coulomb be given to a body. हम बॉडी को इतना चार्ज दे सकते हैं, या बॉडी इतना चार्ज एग्जिस्ट कर सकती है अपने अंडर. What if the answer or the values for number of electrons will come out non-integer value? If it comes out to be a non-integral value, then I would consider no. वो charge exist नहीं कर सकता on that particular body. That is why I have represented like n belongs to integer. It should be an integer. Okay, it should be an integer. It must not be a decimal value. Decimal value नहीं हो सकता. Fractional value नहीं हो सकता. Decimal value, fractional value ये नहीं हो सकता. For example, 2.5, 3.7, not like that. Fractional value 5 upon 7, 6 upon 4, 7 upon 5, like something 11 upon 13, not like that. These are the fractional values. So quantization of electric charge represents that the charge present on a body is always exist in integral multiple of fundamental charge. That is the charge on one electron, 1.6 into 10 raised to the power minus 19 coulomb. Okay. Next thing, the next property of the electric charge is conserved quantity. Conserved quantity, that the electric charge is always conserved, or I would say it considered under the topic of conservation of electric charges. Conservation of electric charge. Okay. Now we must know about the concept of conservation of electric charge, and according to the law of conservation of electric charge, charge can neither be created nor be destroyed. इसको हम ना create कर सकते हैं nor be destroyed, ना हम इसको destroy कर सकते हैं. Can only be transferred, इसको हम सिर्फ transfer कर सकते हैं from one body to another body. Okay. According to the law of conservation of electric charge, the total charge on an isolated system remains constant. अगर हम एक आइसोलेटेड सिस्टम को स्टडी कर रहे हैं, उसमें जो टोटल चार्ज है वो हमेशा कांस्टेंट रहेगा. देयर इज नो इंक्रीज इन द चार्ज एंड नो डिक्रीज इन द चार्ज एज वेल. So what are some of the real life examples we can consider here for the conservation of charge? So if I would consider a glass rod and silk cloth. In the previous lecture, I have illustrated this particular concept. So if I would consider the frictional electricity, or I would rub the glass rod against the silk cloth or silk cloth against the glass rod, then the glass rod acquire the positive charge and silk cloth acquire the negative charge, and the total charge I would consider would balance out and it will be 0. That is why the total charge on an isolated system remains constant, that the total charge is equal to 0. Next case, if I would talk about the concept of radioactivity or the nuclear equation, I would say nuclear equation. What exactly is radioactivity? It is the phenomenon of emitting the radiations like alpha particles, beta particles, gamma particles, spontaneous emission. Okay, so this would come under the topic of nuclear physics. We will understand this particular topic in the chapter of atoms and nuclei. Okay, so if I would consider a parent atom, एक parent atom को consider करते हैं uranium जिसका एटॉमिक नंबर 92 है और एटॉमिक मास इज 238. Okay, now this parent atom decays into thorium, whose atomic number is 90 and atomic mass is 234. This is the daughter atom. Parent atom breaks into daughter atom. Okay, now again, in addition to alpha particle, so alpha particle is presented as helium. So the atomic number for the helium is 2 and the mass number or the atomic mass is 4. So this is alpha particle. That is why it is referred to as radioactivity, because it is a phenomenon of spontaneous emission of active radiations by certain elements, and gives about the alpha particle, beta particle or the gamma particle itself. So how we can define here the conservation of charge, because our main topic of concern is about the conservation of electric charge. How we can see here the conservation of electric charge? Here you can consider the case where it shows uranium. This is uranium. Okay, this is thorium, and this is helium, or I would consider as a alpha particle. Now this uranium parent atom contains 92 number of electrons, and make sure that it supports the quantization of charge, because here it shows an integral value. Now if I would consider the daughter atom, it contains 90 electron, and here it contains the 2 electrons. So according to the law of conservation of charge, total charge remains constant. So if I would consider here as a this portion has 92 electron, and here it becomes addition, so this is 92 electron. So LHS is equal to RHS. This shows that neither the charge is created nor the charge is destroyed, but is transferred from one body to another body. And the total charge on the isolated system remains constant. This is the conservation of charge, or I would say law of conservation of electric charge. Okay. Fourth property of electric charge is that what I have already mentioned in the previous lecture, that we have read it before, like charges repel each other. Like charges repel each other, and unlike charges attract each other. Unlike charges attract each other. So we have considered the two types of charges, positive charge and negative charge. Okay, these are the two types of charges. So what I would consider as a like charge का मतलब similar charges or the same charges. ठीक है, same charges or the similar charges, I would say similar charges. For example, I have positive charge or negative charge. So these are the like charges. अगर पॉजिटिव है तो पॉजिटिव चार्ज, नेगेटिव है तो नेगेटिव चार्ज. And what about the unlike charges? Unlike charges means different charges. For example, I would consider positive charge, okay, and a negative charge, or I would consider negative charge, positive charge. So these are the unlike charges. So the like charges follow the force of repulsion, and unlike charges experience the force of attraction. Okay, so let us consider this is a positive charge, this is a positive charge. They are made or brought closer towards each other. इसको हम पास लाने की कोशिश कर रहे हैं, इसको और इसको, बट हो क्या रहा है, ये दूर भाग रहा है. Here it experiences a force of repulsion, because these are the like charges, and this is the one of the basic properties of electric charge. If I would consider a negative charge or a negative charge, और हम इसको क्लोज ब्रॉट करेंगे टुवर्ड्स ईच अदर, फिर भी ये आपस से दूर भागने की कोशिश करेंगे, दिस इज ऑल्सो एक्सपीरियंसिंग द फोर्स ऑफ रिपल्सन. So these like charges experiences the force of repulsion. And if I would talk about the unlike charges, so let us consider a positive charge and negative charge. And if they are made to brought closer towards each other, they will experience the force of attraction. They will come closer, force of attraction. Or if I would consider a negative charge and the positive charge, and the same process, they are brought close towards each other, they will experiences also the force of attraction. Force of attraction. So this is the case for unlike charge. Unlike charges. So the like charges repel each other. They are experiencing the force of repulsion. That is why we can say they repel each other. Okay. And unlike charges attract each other because they are experiencing the force of attraction. So these are the basic properties of electric charge. So I hope that it is clear what are the basic properties of electric charge. We have discussed about the additive nature of electric charge. We have discussed about the quantization quantity, that the charges always exist in integral multiple of the fundamental charge. We have discussed about the conserved quantity according to law of conservation of charge, that charge can neither be created nor be destroyed but can be transferred from one body to another, like we have seen the case of glass rod and silk cloth. And the total charge on isolated system remains constant, as we have seen the example by using the case of radioactivity, in which the uranium or the parent atom decays into thorium daughter atom and the alpha particle, and the total charge on this system also remains constant. And we have understand about the fourth property of the electric charge, that like charges repel each other and unlike charges attract each other. This is the particular sequence of this particular topic. So I hope that it is clear to all of you. Now in the next lecture I will discuss about methods of charging. We would consider how we can transfer the charge by three different methods: conduction, induction, and friction method. So thanks a lot for watching this particular lecture.